Hello again, the same old project. Here we are, Sunday at noon, and that's McGill up there. Well, it's nothing, how can I say, steady in place, because I'm still experimenting, so I know it's looking pretty ugly. Anyway, it's on the top of the house, it's pretty away from the other roof. Here I have a huge one. Until now it's okay, but I have to show you first of all how thick is the cable. It's almost like the road, you know. So this is a really good improvement, a huge difference. Okay, and here I am up on the roof. So you can see it's a pretty clear horizon on the south. Hopefully my antenna is passing those block of flats there. And that's the way it's looking, my health tech. It's still a work in progress. And here I have the cable. It's damn thick, look, almost like my index. But it's a really good cable. I'm not pretending to be an antenna guru, but I was just thinking about some trigonometry. You know, this is very simple. And let's consider, in my case, we have the McGill antenna, which obviously have a 35 degrees radiation or spread. Okay, let's draw this. It's very easy. So let's consider this is the ground, you know, the ground line. And then, of course, we have a pole. And here is the antenna. All right. Then we have a line parallel with the ground, like this. And that should be, oh, it's not so parallel, but anyway, believe me, it is. So that will be the 6 dB eyesight, you know, ideal, let's call it TX. But it's not like that, because we are losing very easy, like 1 dB at least. And now, 35 degrees, that means 17.5. Okay, so we got 10, and here, this is 1, and then we got 10, and here also. That's to have a kind of, let's call it analog image of the things. All right, guys. So we have from here to here 35 degrees. Obviously, from here to here and down here too, we have 17.5. And also this angle, the one to the ground itself, it's 17.5. Right. So let's consider this pole 20 meters high. Okay. Now let's go to this calculator, and we have angle and one side. We know one side, it's 20 meter, and the angle down here, it's 17.5. And there we go. So that means, okay, this is A and this is B. So that means B is 63.43 meters. So tell me, how is that possible to overshoot anything in 63.3 meters? Do we have a hot spot down here somewhere in this shadow? I don't think so. The point is that, of course, down here we lose a lot of dBs, let's say minus 3 dB. So it's not the same power anyway, or even farther, you know, it's going, dissipate the power. Anyway, the spots should be like 300 meters away, one from another. A 6 dB antenna with 35 degrees angle It's impossible to overshoot anything, even in a very crowded urban area. Okay, let's have another scenario here. Let's have A 200 meters high. Well, I know this is way too much. So if it's 200 meters high, okay, in this case we have a 634.3. Yeah, meters, half kilometer more. Yes, in this scenario you can lose block of flats or whatever, But who's got a spot at 200 meter? I think that's that's something really irrealistic. And if we take the other things, if we consider, let me see. Okay, there we are. So let's take another scenario, okay? This is very simple. 9 dB antenna with a 25 degrees. That means the angle is half here, so we have 12.5. All right, let's put this on. Let's keep the 20 meter pole and let's have 12.5. And that means, let me draw it to see it better. And that means the antenna, it's reaching the ground at 90 meters. Of course, with the lost radiating power. So I think it's very simple to understand that. 7 dB, talk about 2 dB antenna. This is a really omni and very local spread. But the point is that you see the antenna like a 2 dB, because I've been talking about this a lot with my friends, and let's clear this. So this antenna is doing a kind of donut like that, you see? And this is very round and very consistent in a certain area, like blocks or whatever. We go up to 5 dB. Okay, this is 5 dB, let's say. And we don't have the donut anymore because we start having these angles here. So this will turn in the kind of, how can I call it, in a kind of disc with this kind of shape. I can't draw it very nice and very well. But the point is that I think the theory about overshooting, if you use a high gain antenna, I think is just a mistake, because trigonometry is trigonometry and physics is physics. Okay, I hope this is clear. All right, and now let me show you, because we've been talking about McGill and the improvements I have. And look there, this is my traffic in 24 hours. Obviously, it's a huge gain. And now I have 12 witnesses from 4, and I don't, how can I say, I don't blame the success only for antenna, for better antenna. I also consider 4 meters of good LMR 400 cable. Good cable, not fakes, and that matters a lot, because the losses in a bad cable are huge. I tried RG58, like 3-4 kinds, I don't even remember. Top of the sales and top of the shop or something. Okay, buy this one, it's good. I'm using for CB antennas and blah, blah, blah. Well, it's not working. A lot of waste, and I had a cable, I remember, 5 meters turned to be an antenna itself. It was impossible to measure the SWR of an antenna. Anyway, I hope this is useful. A little theory for a Sunday afternoon, and see you soon with news. Hopefully you like this. Push the like button and please subscribe. Subscribing and talking to me, you know, question. I really love to answer question. We'll keep this channel alive. And that is a lot of work, I can tell you. That is a lot of work. But, like I said so many times, don't forget to have fun. I do. Okay, see you later, guys.